start by saying that ever since I was a kid, I was highly fascinated at aging, and I always felt that one of the greatest mysteries was how and why we age and what can we do about it. So to solve that mystery, I think will have a profound impact on our future health. But unfortunately, in the last 60 years since Watson and Crick, the maximum longevity of humans hasn't changed at all, and the expected lifespan of an American has maybe increased only 15% or so, and the current rate of increase is actually lower than it was back in the 50s. So this is a miserable reflection of our approach to age-related disease, and another example of Moore's law in reverse: more money and less return. So why did this happen? I think it's because the medical profession and industry both have been focusing on treating diseases rather than getting to what's the underlying causes of those disease. It's like a handyman who's continually patching cracked walls rather than fixing the foundation. So we need to change our approach and address the root cause of age-related disease, which not surprisingly will reside within the mechanisms of aging. And this should lead, I believe, to significant increases in both health span and maximum longevity, not by better treatments for disease, but by maintaining health and preventing disease from occurring in the first place. So that's a radical thought, but there's solid science behind it. It turns out that our cells have a built-in clocking mechanism, a cell division clock, that ultimately leads to a suicide switch. And we can see that clock at the ends of our chromosomes, the protective tip. So I have a low-tech model here of what's going on. And it may be the exception to the rule about complexity, because this was the subject of the Nobel Prize in 2009 about how telomeres play such a critical role in aging and age-related diseases. So let's pretend that this is one of my chromosomes. It has a centromere at the middle, which is important for segregating replicated chromosomes between cells, and telomeres at each end. If this was to scale according to the size of that telomere, this chromosome would be about 100 miles long. So these are actually very small components, but critically important. So we know that every time a cell divides, due to a process called the end replication problems, telomeres get a little bit shorter. So here we are, I'm losing some of my cell division capacity. And Alyssa Epple will later tell you that stress causes telomeres to shrink, or accelerated telomere loss. So this is for the stress of giving a TED-Med talk. And in addition, we know that lifestyle changes, that lifestyle impacts telomere biology as well. So I missed my morning run. Here goes a few more. And this is for the hot dog I had on the weekend. So, of course, the same thing is happening at the other end of the chromosome. So now I have a chromosome with critically short telomeres at both ends. And what this does, why it matters, is that this type of a chromosome is inherently genetically unstable. It's going to recombine. There will be further breakages within the chromosome, and this leads to loss of the ability of the cells to divide, and ultimately tissues start to fail, tissues and organs, and we end up getting disease and die. So what can we do to address this issue? What are we doing to leverage telomere biology in healthcare? Well, we first discovered that short telomeres may be the best single biomarker of health and disease risk. And it turns out, in fact, that telomere length alone is a better predictor than most of the conventional biomarkers, and independent from it. I'm not saying that we would be looking at telomere length only as a diagnostic marker, but it will be used in combination with others. So monitoring telomere length may be a powerful tool for better health, encouraging individuals to adopt lifestyles that might slow the rate of telomere loss or potentially even activate telomerase, the enzyme that helps maintain telomeres, thus increasing telomere length and consequently lifespan. Now, in terms of therapeutics, we're not quite there yet, but the enzyme telomerase, if you upregulate it genetically, you can see in cells and animal models that the vicious decline driven by telomere loss can actually be reversed. So someday we hope to be able to do this with drugs, and there's already a dietary supplement on the market discovered by John and licensed to TA Sciences, and that gets us partway there. So in conclusion, I'd like to say that this field of science has led us to a doorway through a doorway into a world that was just speculation 20 years ago. We had no idea that telomeres played such a critical role in aging. And solving some of these mysteries of human aging has allowed us to take the first steps through that door and hopefully towards a longer and more productive life for all.
Great. Okay, thank you, Cal. In the next 5 minutes, I may change your view of aging. So we all know that age is the biggest predictor of early disease onset. But it's not chronological age, it's biological age. It's how much our tissue is worn out. And we just heard from Cal Harley how flexible biological age is. Someone could look 10 years younger or 10 years older than their chronological age. So what's all this variance in aging? How can we understand predictors of this rate of aging? It's somewhere in this huge world of gene-environment interactions. And we know that behavior looms large, probably more than 50% of the variance in early disease onset. I'm going to talk about a factor that is not usually mentioned at all, that's invisible, but so pervasive and high level, it shapes behavior and it shapes biology, and that is psychological stress. So let's define stress. If you will, think about the most stressful situation in your life recently, and think about how you felt in the midst of that, coping with it at its worst. How did your body feel? What's the stress response? We know it well, that reptilian brain. We feel maybe tense, our heart rate goes up, our thoughts may race, our blood pressure grows up. This is the fight or flight response. So that's stress, right? Okay, I'm done, that's stress. So now you know what stress is. No, actually, that's the old story of stress. So that's a small part of the picture. We now know that stress seeps into the cell and changes hundreds of important biological processes, including rate of aging. So I'm going to focus on telomere length, this integrative measure of how cells age, the clock or pacemaker on the cell's life. About 10 years ago, I was very fortunate to collaborate with Elizabeth Blackburn, who discovered the cell aging system, and start a journey of trying to understand the malleable factors that affect rate of cellular aging. So we wanted to look at people under extreme stress. So we looked at mothers of chronically ill children, and we compared their telomeres to mothers of low-stress children. And the findings were remarkable. Their telomeres were dramatically shorter. This finding has now been extended to many conditions of suffering: depression, anxiety, exposure to trauma. So it appears our cells are listening to our suffering. Now, what is suffering? It's just a complex topic, but it's interesting to think, what is chronic stress and how do we measure it? I have a mnemonic for you, which is chronic stress is in part R&R. Not the good kind of R&R that you're thinking of, not rest and relaxation, but seeing red and rumination. So what is seeing red? This is the mental filter. Some of us are so good at interpreting danger and exaggerating danger, and especially threats to our ego. These are the types of chronic stress, the types of thoughts that are linked to shorter telomeres that really get our stress system activated. And rumination is when we carry around stressful thoughts long after the event happened, far into the future. In fact, some of you might still be having a few intrusive thoughts of that stressful event I made you recall. And that's an example of how rumination is, how sticky those negative thoughts are, and how we carry them with us and keep the stress response alive. So we now know that stress exposure, stressful thoughts, these are the things that dwindle our telomeres. But I'm going to take you to the new question, which is, do our cells know when we're doing well? So stress is time traveling, worrying about the future, ruminating about the past. Well-being is in part being present in the moment. So meditation is an example of training the mind to be present. Our collaborators at UC Davis recently finished one of the grandest studies on meditation. They put people up on a mountain in Colorado for 3 months and trained them in meditation. They compared their cell aging to a waitlist group, and they found that they had slowed cell aging in the meditators. So we've been wanting to look at that in people who are not meditators. So we started measuring mind wandering and presence of mind. And I'm going to show you, Sally will demonstrate for us what our findings are. So Sally can respond in two ways. On a good day, she's noticing what's in front of her, noticing the flower, so to speak, and she's able to be present and engaged and focused on what she's doing. It's a pleasant feeling. On a bad day, Sally is everywhere but here. Sally's thoughts are thinking about urgent things, timelines, work, her to-do list, lunch. Her thoughts are mind-wandering. So we found that the more mind-wandering and the less present focus and engagement in the moment, the shorter people's telomeres were. So you can see mind-wandering Sally has more dwindled telomeres, which does translate into more of an immune senescence, an aged immune system. So what do we do with all this knowledge? It appears our cells are listening in and eavesdropping on our thoughts, whether they're stressful thoughts or it's a state of mind of presence and focus. So some of you still might be thinking stress is just in the head and doesn't get into the body. Look at today, the front page of today's USA Today. 40% of people are more stressed since the recession, more stress at work. We have an epidemic of stress. You might think about stress as a potent drug, and many of us are on high doses for long periods, and we don't even know it. It's invisible. So how do we take this into account? The implications of this mind-to-cell relationship are so vast, and we need to take them into account. Not just superficially offering a yoga class at our healthcare center, but in our institutions, in our schools, in our workplace, in our social interactions. We need to take this relationship into account as if our cells and our lives depended on it, because at a very fundamental level, they do. Thank you.